Hey everyone, and welcome. Today, we're going to dive into a technology that's pretty much invisible, but, well, it literally builds the world around us. It's called CNC, or Computer Numerical Control, and it is the absolute foundation of modern manufacturing. Let's get right into it. I mean, just look at the phone in your hand. Feel that perfectly smooth metal case. Or think about the incredibly complex parts inside a car engine. That amazing millimeter-perfect precision? That's not an accident. It's only possible because of these super sophisticated automated machines working behind the scenes. And believe me, this isn't some tiny niche market. The global industry for these machines is on track to hit a staggering $140 billion by 2030. So this is way more than just factory gear. It's a massive, booming industry that is, in a very real way, shaping the world we live in. But, to really get a grip on where we are now, we gotta go back in time. So what did manufacturing look like before computers were running the show? Well, the first big leap forward was something called numerical control, or NC. The best way to think about it, it's like an old player piano, with the paper roll and all the little holes that tell it what notes to play. It's basically that, but instead of playing music, those holes are instructions telling a giant metal cutting machine exactly what to do. So why even invent this? Well, it was all about solving the classic problems of manufacturing. See, humans, we get tired, we make mistakes, and trying to make two complex parts exactly the same is incredibly hard. NC was designed to crush those problems, to bring in speed, consistency, and a level of accuracy nobody had seen before. And this table, man, it really shows you what a huge deal this was. Before NC, you had what were called special-purpose machines. Think of a printing press built to only print today's newspaper. Tomorrow, it's useless for the new edition. NC, with its swappable tape, was a total game-changer. You could make a few of one thing, then just pop in a new tape and make something totally different. This was really the first flicker of the mass customization world we live in now. And when you break it down, the early NC system was actually pretty straightforward. You had the program on the tape, that's the what to do. You had the machine control unit, the MCU, which was the brain reading the tape, and then you had the machine tool itself. That was the muscle doing all the work. Simple, but absolutely revolutionary. But then, everything changed. The moment that took this really cool idea and launched it into the stratosphere. Yep, I'm talking about adding that C. The computer. And just like that, we get CNC, Computer Numerical Control. The massive change here was ripping out that physical, clunky punch tape and putting a dedicated computer in its place. This wasn't just a simple upgrade, it was a total brain transplant for the machine. And wow, what a difference that made in the real world. With the old NC tape, if you made one tiny mistake, you had to repunch the entire tape, a total nightmare. With CNC, you just edit a line of code on a screen. All of a sudden, machines could store tons of programs, react in real time, and were just infinitely more flexible, all because of software. All right, so we've got the what. Now let's get into the how. How does this thing actually work? Let's pop the hood on a modern CNC system and see what's going on inside. The best way to think of the computer inside a CNC machine is like a master conductor of an orchestra. It's juggling all these critical tasks at once. It's reading the program, the sheet music. It's precisely controlling every single movement. It's managing all the different tools. And it's constantly watching the whole process to make sure nothing goes wrong. It's an insane, high-speed, high-stakes multitasking job. Okay, now this is a really, really important idea here. Open loop versus closed loop. An open loop system is kind of like throwing a ball with your eyes closed. You give the command and just hope it lands where you wanted it to. But a closed-loop system, that has feedback. It's like watching the ball's entire flight path so you can adjust your next throw. It's constantly checking its position and correcting itself. And that is how you get that insane micron-level accuracy. So how do you actually talk to one of these machines? I mean, you can't just say, hey, make me a bracket. You have to speak its language, a very, very precise language that turns digital code into a physical thing. Well, it has its own alphabet, a special language made of different codes. G-code is the star of the show. It handles all the geometry, telling the machine where to move. But it can't work alone. You've also got M-code for other functions, like turning the coolant on, F-code for feed rate, how fast to move, and S-code for spindle speed, how fast to spin the tool. It's like a perfect, repeatable recipe for making just about anything.
Now, what a machine can actually make really depends on how many ways it can move. We call these axes. The simplest are two-axis machines, like a wood lathe. They just move a tool in and out, and back and forth. Simple, but effective.
From there, we step it up to what you'll see most often, the three-axis machine. This adds that third dimension, so you can move left-right on the x-axis, forward-back on the y-axis, and up-down on the z-axis. With those three movements, you can start carving out all sorts of complex 3D shapes. But why stop there, right? This is where things get really wild. A four-axis machine adds rotation, and then there's the five-axis. This is the big leagues. We're adding two rotational axes. This means the cutting tool can get to the part from almost any angle imaginable, allowing it to create these mind-bendingly complex shapes, like a turbine blade for a jet engine, all in one go. Okay, so we've gone through the history, the tech, all the nerdy stuff, but what's the big picture? Why does this all matter? Let's connect all these dots back to the world we all actually live in.
Honestly, the list of what CNC does is kind of endless. Because, you see, CNC isn't just one machine. It's the brain that controls all sorts of machines. Mills, grinders, laser cutters, even 3D printers. This tech is used to make everything from the most critical parts in an airplane, to custom-fit medical implants, to the very device you're watching this on right now. So if there's one thing to take away from all this, it's this. CNC technology is the quiet, unsung hero of our modern world. It is the fundamental engine that drives automation and allows us to make things with a consistency and a precision that, just a few decades ago, would have sounded like pure science fiction. And that kind of leaves us with one last big question. We've seen this technology go from punched paper to machines that can basically sculpt metal like it's clay. As they get even smarter, faster, and more capable, it really makes you wonder, what's the one thing you wish they could build for us next? Thanks for joining me.